This is our mechanics of solids lab. Hello JP sir. Hello Raghu sir. Yeah. So we are having this setup. This is the first important setup. We are having a universal testing machine, a very important machine which is used to determine the mechanical properties, one of the most important mechanical properties of a particular material. Say, for example, if I want to find out the strength of the material, say it can be Young's modulus. In the case of a tensile test, when we apply the load, if it is a tensile load, so if I want to find out where the material is getting failure, so that can be determined by using this machine. It's a very important machine. It is used to determine the strength of the material. One of the most important property, that is we call this as a tensile test, is done by using this machine, universal testing machine. Here you can use when we come to the experiment, we'll describe everything. So this one is one of the experiment that can be done by using this machine, universal testing machine. Now let us slowly enter into the next one, as a torsion test machine. Here we will find out what is torsional strength, shear stress. So there are certain formulas based on some important formulas based on which we will calculate the other unknowns. You find out 3 unknowns first. Of course, the length and the radius of the particular rod that can be determined. Other things, say torque or shear stress or modulus of rigidity or polar moment of inertia. Other things can be determined. You just try to find out 3 unknowns there. So this is the machine which is used to find out torsional strength, or it's a shear stress. You can determine the shear stress by using this machine. So that will come under calculation part, of course. Now this is a impact machine. It is used to find out what is the impact of the that is taking place over the given particular material. Sudden shocks, if it is given, what should be the strength of the material such that it can resist or it can absorb the sudden shocks that were applied to the type of machine part or the material. So depending upon the material and the type of hardening methods will decide the strength of that material, and this is described by using IZOD or Charpy test. So this is the machine. Next one is a compression testing machine. It is used to determine what is the compression strength of the material. Compression test, where the material is getting completely sheared off, that can be determined by using this compression testing machine. Next, Rockwell and Brinell hardness test. To determine the hardness of a material, we use this equipment, Rockwell and Brinell hardness test, and we have this machine. It is used to, you have got some readings here. So these readings will help us while we perform the experiment. Next one. And we have got one more machine, electrical resistance gauges. It is used to determine the strain. So generally we call this as strain gauge. To determine what is strain, we all know the strain is change in length by its original length. That can be determined by using this setup. It's an experimental setup. Of course, all we study the calculations and theoretical part in our subject, but coming to the practical, we will find, in some cases, we will find the direct machinery to find out the properties. So in that, this electrical resistance gauge is one of the type. It is used to determine the strain of the given particular material. Next one, spring testing machine. This is the machine setup. It is used to determine the stiffness of the. So in this we will find not only the stiffness of the spring, we determine modulus of rigidity because it is subjected to the shear stresses. So when it is when the type of loading creates the shear stresses, depending upon that we will go for the calculations, that is shear, that is rigidity modulus. So we calculate the rigidity modulus, deflections and the spring stiffness by using this spring testing machine. Next, coming to the next setup, we will use a simply supported beam will be here, over which we apply the loads in the center. Not only simply supported beam, we can also use the same setup for fixing the cantilever beam. You can change this support. You have a provision to change this support to do the experiment to find out the deflection of the beam. You can find what is the deflection of the beam. This is, of course, this is the cantilever beam, and you can use this rectangular bar. If I keep this over the two supports, then that will be a simply supported beam, and we have got some weights here. Each weight, it weighs of 1 kg here, and this is, and it is of and this is of half kg, and this is 1 kg. So we keep the weights like this, and we will find out what is the deflection for what, how much weight, how the deflection is taking place. And finally, we calculate for Young's modulus of the given particular material with the help of the deflection of the beam. And myself, Madhu Sirikonda, I am going to deal strength of materials lab. Thank you.